Right, before we can differentiate this, you still have to remove the brackets. And the thing about removing the brackets here is you've got to do the root of x times x squared, and you've got to do the root of x times the root of x. Now, I can do the root of x times the root of x quite simply, because that's just going to give me x. But the hard bit is doing the root of x times 2, or sorry, the root of x times x squared. So, to help you do this, it would be useful to change the root of x into an index, and it's got the power of a half there. This one here is x squared, and the last one, you could leave it, but because you're dealing with all the other ones that have got powers, you might as well change this one into a power as well. So now we're going to do the root x to the power of a half times x squared. The bases are the same, so you just add the indices together. So a half plus 2 is 2.5, and 2.5 can be rewritten as 5 over 2, because it's 2 times 2 plus the 1, which is 5 over 2. So we've got there x to the power of 5 over 2. X to the power of half times x to the power of a half. Add the powers, it's 1. So it's just going to give you x to the power of 1, which is just x. Now that it's ready to differentiate, dy by dx, you bring the power down to the front, you take away 1 from the power, and this one here, because it's just x on its own here, the power there is 1, so 1 comes down to the front, take away 1 from the power, it becomes x to the power of 0, and anything to the power of 0 is just 1, so that's why it just remains as 1. So that there is your differentiated function.